students, so here we are with the question 5th of the exercise 1.2 of the chapter real numbers. So the question 5th is check whether 6 raised to the power n can end with the digit 0 for any natural number n. That is, we need to check whether or no 6 raised to the power n can end with the digit 0 or no. Before doing this question, let us learn some facts. What the facts are: any number that ends with 0 is multiple of 10. What it means is that any number whose n digit is equal to 0 will definitely be the multiple of 10. Means on dividing that number by 10, the remainder obtained will be 0. Example we can give in this case is 10, 20, 30, 100, 200 and so on. Means as all these numbers has their n digit 0 and on dividing these all numbers the remainder obtained will be equal to 0, means these numbers are definitely a multiple of 10. That's what this statement means, that all the numbers whose n digit is 0 is a multiple of 10. And also same number is multiple of 2 and 5. As we know, 10 is equals to 2 into 5, means 2 and 5 are the factors of the number 10. So any number which is divisible by 10 will definitely be divisible by both 2 as well as with the number 5. We can also check this from the divisibility rule of 2 and 5. The divisibility rule of 2 says that any number whose n digit is 0, 2, 4, 6 or 8 is divisible by 2, and the divisibility of rule of 5 says any number whose n digit is 0 or 5 is divisible by the number 5. So the common terms which we can obtain from the set of the values of 2 and 5 is 0, which means that for the number to be divisible by both 2 and 5, it has to be its n digit equal to 0. So if the number has its n digit equal to 0, then the number will be divisible by both 2 and 5 as well, and in return that number will be the multiple of 10. So now here in this question the number provided is 6 raised to the power n, where n is any natural number. Now let us take the cases in which n is equals to 1. Then 6 raised to the power n, that is 1, will be equal to 6. Now let us take n is equals to 2, then 6 raised to the power 2 is equals to 36. If n is equals to 3, then 6 raised to the power 3 is equals to 216. And if n is equals to 4, then 6 raised to the power 4 will be equal to 1296. So what we can observe that in this pattern where n can be equal to 1, 2, 3 or 4, the n digit is always comes out to be 6. There is no other digit is obtained in the n digit of the numbers for the number 6 raised to the power n. If the n digit is 6, then means this number is a multiple of 2. Right, as per the divisibility rule of 2 says, but it is not a multiple of 5, because for the 5 the n digit needs to be 0 or 5. So the number which is a multiple of 2 but not a multiple of 2 will result into not a multiple of 10. And if the number is not a multiple of 10, then its number n digit will not be equal to 0. If we take the reverse of this statement, this is what it says, that a number is a multiple of 10 if the number has its n digit 0, and as it is not a multiple of 10, means that number will not have its n digit equal to 0. So from this very conclusion we can say that 6n is always even, as it is a multiple of 2, but never ends with 0. which was asked in the question to check whether or not the number ends with digit 0. So this was all about the question 5th of the exercise 1.2. I hope this question is clear to all of you.